VRRP, HSRP, GLBP. Well, what are all those acronyms about? Well, find out more right here on IT Pro TV.
You're watching IT Pro TV.
Just when you didn't think that there could be more acronyms in the beginning of a show, we're going to throw at you FHRP, which I just about massacred here. But the guy that's going to help us get all that straight and help us understand this configuration a little bit better, Anthony Sequeira.
Okay, so everyone knows my weakness. Let's see if I can get these right. There are a bunch of first hop redundancy protocols. There's hot standby router protocol, virtual router redundancy protocol, and gateway load balancing protocol.
That is awesome.
I just got my CCIE in acronyms. Again, I'm not good at that, so that was a stretch. So let's begin our discussion with the original recipe, and I hope that I don't get sued by Kentucky Fried Chicken for what I just said, but it's the classic. It's the hot standby router protocol. It is a Cisco invention. It took the networking world by storm, and it turns out that there are two versions of HSRP. And what I want you to know, wait a minute, we better back up the truck for a second. If it's been a long time since you've studied at the CCNA level, what we are talking about here is having multiple default gateways. Having not just one default gateway for our clients to get out to the enterprise, get out to the internet. We're talking multiple default gateways. That is a hugely advantageous thing. We don't want to build networks with a single point of failure. If one router goes down, we don't want that to be the end of connectivity for all of our clients. So that's what first hop redundancy protocols are all about. Now, the two versions of HSRP. There's version 1, there's version 2. So many times with Cisco networking, there will be compatibilities between versions. This is not one of those times. Different packet types, different multicast groups are in use. Don't try and mix these. What you would do is if you had to go to version 2 to take advantage of that feature set, version 1's the default. If you had to move to version 2, you do it one router at a time in that HSRP group. You could take down the active device, and when you do that, another device comes up as active, so you can do it seamlessly without causing traffic interruption. But again, please, I think I've made it clear now, you can't mix and match those two and have a happy HSRP environment. Now, interestingly, what about V6? Well, yes, there is an HSRP for V6, but it is separate from the V4 functionality. So this isn't one of those times where the protocol can just seamlessly handle both. An example of that would be OSPF version 3. OSPF version 3 can seamlessly do V4 and V6 in the same environment. That's not what we're talking about here with HSRP. It would be a separation of those functions when you're doing both V4 and V6 work. Now, for the longest time, HSRP was it. And then we had two more entries into this arena, and it's VRRP. VRRP, Ronnie, of the three, is the standout because it's not Cisco proprietary.
Right.
And I got to tell you, one of the things that I assumed for probably like a full year was I assumed GLBP was an open standard. No, turns out that awesome protocol, another Cisco invention. So Cisco has certainly been at the forefront in this area. But back to VRRP, it is almost identical to HSRP. You have to really squint to see the subtle differences between it and HSRP. They're not even that significant. So just think of it as your open standard HSRP. Now, when we get to GLBP, things do change dramatically. What's going on is you have one of the devices in the group that is doing a very special function. It's called the active virtual gateway. and it is in charge of load balancing. Isn't this great? The load balancing is automatic. Yes, you can load balance in HSRP and VRRP, but it is an administrative nightmare. I mean it, a nightmare compared to Gateway Load Balancing Protocol, where the load balancing is fully automated. And not only that, you can tell the AVG just how you want the load balancing to take place.
Right.
If you want simple round robin, you tell it to do that. If you want weightings where you're like, I want that router over there to get most of the traffic, you can configure that. But right out of the box, it does the load balancing for you. The default method, we don't need to know. I would guess by default it's load balancing, round robin, right? That tends to be the default with load balancing if you don't go in and specify something different. But it's so great that that load balancing happens for us automatically. You've got the active virtual gateway, and it is playing with virtual MAC addressing to ARP requests in order to just dynamically distribute the traffic. It's such a simple, clever design. And then your other routers in that group that aren't in charge of doing the load balancing, they're what we call active virtual forwarders. Don't forget the AVG can also forward traffic. So technically it's also an AVF in what it can do, but it gets the very special name of Active Virtual Gateway because it's responsible for the load balancing. Well, let's take a look at some of this at the CLI, and we decided to pick HSRP. It would certainly be the emphasis if there was any configuration asked of you here or knowledge of config, it would be HSRP. Ronnie's going to fire up a topology he built for us and show us some of this.
Yeah.
The first thing that's funny about this is the command is not HSRP.
Yeah.
It's IP standby.
Yeah, it's
right?
standby,
So that's
yeah.
the first thing you got to remember. I know I did it.
Right.
The first time I was configuring this, I did like HSRP question mark on the router. And I'm like, uh-oh, it's not there. And that's because the command set is IP standby.
Right. All right, so let's take a look at our topology as we get started here, because this kind of sets up everything. Most of you probably already have done this, but if you haven't, let's take a look here. So when Anthony was mentioning the idea of actually setting up multiple gateways, that sounds like a great idea, right? So here it is inside of this blue area. Let's take that as being our local area network. And I have a server here set up as being something that we can use as an example. It's hooked up to a layer 2 switch, as you see right here in the center. And there it is. I can have a gateway going out of this router 2 is what I named it, or router 3. Now, Anthony, there is a problem if I actually set that up, okay? Because what if I actually have a packet that goes all the way out, goes out to the internet, comes back on the other router coming back?
Ooh, yeah, that
would be
asymmetric pathing. We tend not to like that in networking.
Yeah. So that's why the idea of actually doing this first hop redundancy protocol helps out. And the reason why it does, because we're not actually going to use the IP address that's on this interface over here on router 2. We're not going to use an interface over here on router 3. When we configure this, it's going to create essentially a virtual IP address for us that we're going to now take and put that on our test machine is what we're going to do.
Yep.
Yeah.
And I love that you use the correct terminology there. So that is the virtual IP. You'll hear a lot of people say like the phantom IP address or all this clever terminology, but the correct terminology is VIP, virtual IP in HSRP.
Yeah. Now, to help us to test this out and everything, and I'm glad Anthony gave me this one because it's the simplest commands I can actually do, but I also have a loopback of quad 1s up here on this router that we should be able to test if it actually works out. So on my server down here, I've already configured it with that virtual IP address that I'm going to use for its default gateway.
Okay.
So this one over here is going to actually have a .2 for its address as far as the interface go that's connected into my LAN. This one over here ends in a .3 is what this one ends in. So I need to configure both of those routers to use HSRP to do this. So let's go over to our command prompt or to our terminal here and to the CLI. I'm mixing up different ways of actually describing all this stuff. But here on router 2, let's go ahead and we'll do a configuration. And
so you've done nothing on this device as far as HSRP goes?
Nope. Yeah, okay. I've set it up to make sure that we could get IP address connectivity, things like that. Okay. And also on the internet side, I've set up routing so that we could actually get a bounce back that, with the pings that would help us out. Now, once we have that, I've also configured, this is Gigabit Ethernet 0/1. This is the one facing my inside. So my LAN IP address, and it's got an IP address already on it. So the command itself is I always forget the B for one reason or another.
And that's funny. I said IP standby. I had it reversed. It's standby IP.
Yeah. Actually, there is one more thing, which is a group number that we'd also have to set up.
Gotcha.
Now, I always just use one because it's simple, but you can actually create multiple ones. I've done that before, but not to actually try and do anything else, but to see if I could do it. But you can create multiple ones, which I'm not sure why I would be able to do that.
Well, yeah, one key case of that is when you are doing load balancing.
Yeah.
So you're setting up multiple HSRP groups, in order to do the load balancing.
Yeah. So this is where that keyword that Anthony's been talking about comes in, IP. Now, once we do that, we now pick out an IP address inside of our pool of IP addresses that is not going to be used. Okay. So you need to make sure it's not going to be used. It can be anything in that pool, but it just has to not be used.
Okay, so you have the .2 consumed, you have the .3 consumed, so you made .1 the virtual IP.
Yeah, it's just my way of labbing. I always, for one reason or another, I've always chosen a .1 as being a default gateway, so I was like keeping that.
That's great. That's great design.
Yeah, so I've kept that, and Anthony, believe it or not, that is pretty much enough to get us started. So the first time I ever did this, there's no way that this is going to do all that fancy stuff that I've been learning about, that I talked about here.
Sure.
There is no way that this is actually going to work here. So I just sat here and I looked at it. And I was like, okay, well, let me configure the other side. So we're going to go over to router 3, right over here, and make sure I'm actually in the correct interface as well. So the neat thing is about this in lab environment, Anthony, I made sure that both of these interfaces was 0/1. So it made it easy for me. Now, in a real environment, you're not going to have that luxury.
Make sure you're on the right interface.
Yeah, make sure you're on the right interface is key. So it's essentially that mirrored interface that's facing my LAN at this point. And then the same thing, standby 1 IP 192.168.23.
And the group number here is interesting. This is one of those rare cases where the identifier is important.
Right.
So that does need to match on both these devices. It's not locally significant.
Yeah. So now in the background, there's a bunch of things happening that's going on. And usually if this is anything, you're like, did it actually work? Did we do anything? So at this point, I like to do a show. And this is kind of the key as show standby. And it's right here, okay, that we're actually taking a look. And we'll see that we also got a notification as well.
Oh, I
love
it.
So if I take a look, I can now see there's that group 1 that Anthony was talking about. There's the virtual IP address. Now, there is something else that's actually special about this too. Anthony, do you know that this particular IP address right here is used by every single one of these when we go to the virtual IP? So it creates a virtual MAC address at the same time, and it's identical for every one that you ever set up.
Yes, and that changes when we do gateway load balancing protocol, because there's still the concept of virtual MAC address, but now the virtual MAC addresses are unique for the different active virtual forwarders, and that's how it's doing the load balancing. So it is somewhat of an extension of this technology.
Yeah.
But this is great, Ronnie. And by the way, I wanted to bring up, in our lecture portion of this, we were talking about how you have to really squint with VRRP to see differences. One subtle difference, the virtual IP in VRRP can be one of the IPs from your devices. So just little subtle differences like that.
Yeah, and I can see the use for that. If I already have like my DHCP server already set up for one of those and I don't want to change it, but I still want to be able to do something like that. But here I like to actually set it up this way.
So this device you're on right here, Ronnie, R3, I see that we got a system notification from HSRP level 5, and I can see that we went from the speak state to the standby state.
Right.
So that's telling me that all of the forwarding now is going to be going through the R2 device.
Right.
We're just sitting here in standby mode. We won't be used unless there's a failure of the R2 device.
Yeah, so you can see that right here. So I typed in my show command right before it actually picked up on HSRP. It says, hey, we're competing now, right? Both of the routers were actually speaking, but then they got together and they ended up talking about it. And you can see where it declared itself the active router, now as well. Now you can see here where it actually switched to the standby state is what it actually did. So it went ahead and it switched that from where we actually had speak right at the beginning, and we see it actually switched here to standby.
That's cool.
So it actually does show us that. Now let's go over to router 2, and we'll run the same command here.
I just want to make sure I got this right. That's R3 that we're on.
Right.
And it was reporting who the active was.
Yep.
Okay, got it.
So now we should take a look, and we should see where it says that the state is active. And also, let's take a look at just some other things. And this is how you can also tell which router is going to be active. You notice that this one says, hey, it's this guy. It's me right here that I can do that. The standby router is the other IP address to help us out. Now, if this isn't working, Anthony, then on my test machine, I shouldn't be able to ping that virtual IP address. It shouldn't even come up. So if I can do ping 192.168.23.1, well, I'm getting that. Remember, this is not an IP address that's out there. I only had .2 and .3 configured, so now I'm actually getting that string of pings. So, Andy, that seems like it actually works the way that we want it to, but the real test, though, is if this is my default gateway, is to ping
you're going
something.
to ping the internet.
Yeah,
yep.
Somewhere out on the internet. Now, this is fake on the other router here, but look at that. So it is now pinging. Now, which of those two routers, what we saw, that's actually router 2 that is in that speak state. So we know that that's the active router, so it's actually going out through router 2 is what's doing it, okay?
Can we do a trace?
Yeah, we should be able to do a trace as well to tell.
Yeah.
So let's see, trace
the quad
route. And let's see, it's not actually loaded in this particular program.
Oh, that's okay, yeah.
So this one won't work in that way. So it's part of the Cisco viral here that's not actually part
I forgot we were
Yeah.
on an actual host.
Yeah.
That's a Unix host, so that's pretty cool.
But it is working this way. Now, the key is, what happens though, Anthony, if I actually leave that running, okay? Now, let's simulate this idea of a failure.
Yep.
So let's see what happens here.
An easy way to simulate the failure, I imagine, would be to down the interface?
Yeah, just down the interface.
Okay.
So I'm going to go back to router 2, and we'll just issue a shutdown. Now, once we issue the shutdown, we're going to give it a moment, and notice it actually went from active to init. It's changing it. It is now shut down. Over on router 3, it actually already went from standby, to active.
Okay.
And let's see how many pings we ended up dropping. So if I scroll back up here and look at that, Anthony, we haven't dropped a single ping doing that. Now, sometimes you will. Sometimes you might drop a few pings as you're doing that. Depends on the latency that's going on and other things that are happening. If your network's really busy, you might find it drops few pings.
And you did a shutdown of the interface, so that was kind of graceful,
right?
But in reality, it could be that the interface is like flapping up and down, and then there would be the cutover, and we could lose packets. So the way in which we did it, no packet loss whatsoever. But so cool. What a great demonstration.
Yeah. Now, Andy, what if we come back up, though? Okay. Does this become the standby router again?
Okay? Oh, yeah. I remember this.
We want to actually do. So
this has to do with preempt.
Yep. So at this point, let's see something. Actually, I didn't even have to do that. So right at the bottom of the screen, Anthony, it said, hey, no, I'm still in standby. So it started to do it, and it said, I'm still in standby. And the reason why that is because what Anthony just said is that there is another keyword that we can issue that tells the routers to say, yes, I want to preempt this. So in other words, I always want to be the active router. If I'm not, make me the active router. Then we can actually do that.
You can go in and you can set HSRP priority, right? And you could say, all right, based on HSRP priority, this router right here should always be the active forwarder. And then you can turn on the preemption feature. So like Ronnie was describing, when it comes back up, it wins the election again for the active device.
Yeah.
So cool.
So if we take a look at this, here's the command right here that says preempt, and that's what it's doing. Now, there is another command for us that I want to make sure that we do take a look at, which is, since you mentioned it, priority. So the default priority is 100. That means if it has to go down and comes back up, you can set the priority higher. And that will automatically guarantee if it goes down, comes back up, if it's the highest one in our group here, then it will also become that active router as well. So you see where we can actually do a combination of this. You can do a priority 200 if you want to, or 101, because the default is 100, and that sets it higher and goes, all right, we're going to go through this, and yeah, I'm still going to come out to be that. Or if you want to take that kind of and force it, you do preempt, say, I don't care what state it is right now, as I actually don't care whether it went down or not, I want to take over. You can also do the preempt, and that will also help too. So those are pretty much the commands that we can take a look at, as well as show commands to help us out here.
I love it, Ronnie. There's maybe one last thing I would mention about HSRP, and really then you've seen anything they could possibly ask on the config. There's one last concept. Ronnie, if you could pull up, if you don't mind pulling up the topology again. There's one last thing to think about here, and that is what happens if the R2, let's say R2 on the left is our active forwarding, gateway. Right. I shouldn't use that terminology because it's for GLBP really, but so that's the active device in the standby group. So it's doing the forwarding. What happens if its interface on the non-LAN side, its internet-facing interface fails?
Yeah.
Well, then it stays up and people can't get out to the internet. Right. So the one thing to think about is interface tracking that we can configure. And it's so simple. You tell those devices, track those interfaces that lead out to the internet. And if those interfaces go down, you can have it decrement the priority. Make sure you use the preemption feature, because now what's going to happen is the interface out to the internet fails. It'll decrement its priority. You've got preempt in, and now your neighboring gateway will preemptively take over because of the fact that the key interface failed. So interface tracking can be tied in here, and I, again, doubt very seriously you would need to configure something like that in the Encore exam, but it sure is great to know about.
Yeah, it's a great use of that IPSLA type of thing to be able to do.
Oh my gosh, that's another one, Roddy. We could tie in IPSLA. That's really cool. So now you're having the routers ping some destination, and if they can't get there, decrement the priority based on that. So you can get pretty fancy, but where HSRP breaks down is load balancing.
Right.
That's the huge challenge. That's why Cisco invented GLBP, to just take care of that for us. And the GLBP configuration is like so similar to the HSRP.
Right.
But a lot going on different behind the scenes.
All right, Anthony. Well, thank you for helping us to actually take a look at all these concepts for the first hop redundancy protocols. They are all great things that you can actually learn a bit more about how the network actually can function. You can keep it up and going as well. Well, that's a great place for us to end this episode then. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.